Today NBM we're gonna continue our discussion on question 6. So we have a box that been pushed upward in inclined plane with the force F in this direction and a constant velocity 0.8, which means the acceleration is equal to 0, and we have a object surface that make contact into fluid with the length of 50 centimeter and wide of 20 centimeter, been given a variation coefficient. So in this question, as you can see roughly, it is the 80% dynamic. So I'm not gonna go detail about the free body diagram, but if you want me to explain it, I can make another video. Please like and subscribe, by the way. Okay, like any other dynamic, you need first doing the FBD. So this is the FBD. You have a box. We have a force that been exerted in this direction. We have a weight that you need to be compute into x and y component later, and we have a Fn, and we have a friction force. And in FBD we didn't need to compute the kinematic magnitude here, but because I'm combining the kinematic and kinetic in one diagram, so that is, you have it. So there is the trigonometry energy, trigonometry force for F. As you can see, it can be computed into x and y component. So we make an analysis at the x component. We attempt to find out what is the force exerted here. So F minus by Fx minus by Ff equal to 0. So essentially, because the object moving, this must be equal to ma, since that a is equal to 0, so that's why here you get 0. Rearrange this equation, thus you will get F equal to Fx plus by Ff. Compute F into x component, and F of friction force is equal to normal force times by coefficient of friction. So there is a coefficient of friction, so there is a normal force, because the normal force essentially make analysis upward direction. For example, in y component, thus you will get n, you will get plus pi minus pi fy weight in y component, and you will get the exerted force in y component F sine 20 equal to 0, because in y direction there is no movement. So that's why you can rearrange this equation, and is equal to Fy minus by F sine 20. So that's why here Fy minus by F sine 20. So that is where is origin come from. Times by the coefficient of friction. Rearrange this equation, substitute the value, thus you will get this equation, and substitute the value of W, and the value of Fn. There is not Fn, there is Fy. Here is Fy 0 negative 0.027, include value of weight, so Fy essentially it is the weight in y component, so that's why 115 cos 20 minus by 0.27 F sine 20, and rearrange this equation, you will get F for exerted force equal to 86.59 Newton. So that's how we answering question number 1. B, the oil have a thickness of 0.4 millimeter and have a dynamic viscosity 0.012. Determine the percent reduction in required. So we need to find out what is the force, friction force that been applied due to the fluid itself. So using a formula within relationship of coefficient dynamic viscosity and this relationship, just plug in the value, thus you will get the friction force equal to 2.4 Newton. The direction of this force in this direction, the direction of the movement of fluid itself. So that's why in here we taking back from where? From here, the product of this force we need to minus by the force that we plus by the force that we get. Minus by the force that we get to indicate that the effect of oil will reduce the force apply because we have a less friction, right? So that's why we get F nu equal to 84.26 and we make a percent difference calculation, we get 2.69%. So I didn't have a final answer for this, so maybe if you can classify either my workflow is correct or not, but I'm confident that the workflow itself is about 80% correct, but maybe some value like that I miss up, but 80% of this flow I'm confident is right. So if you can classify for me, comment down below. So I think that's all for today. Thank you for watching and have a nice day.